All right, so I'm Hans. I'll be your host for the evening, and we're going to be talking about test driving your product. I've given a presentation about 2 months ago, I think, for test, getting your feet wet in test-driven development. So, I'm kind of building a little bit on it, but not too much. So if you have any questions, uncertainties, or doubts on what the heck are you talking about, feel free to interrupt me. You can unmute yourself and ask any question throughout the presentation. You don't have to wait until a designated time or anything like that. That doesn't mean that there won't be questions at the end. There'll still be questions or a time for a Q&A after the presentation. So, whatever you prefer, it's okay. Cool. So I'm gonna just get started. And before we get started, I want to tell you a little bit more about me, the person you all came here to see. Sorry, that was a little bit of a joke, of course. I'm a software engineer at Integral, and I have a little bit of experience in projects that range from absolutely no automated tests to testing after the fact and completely test-driven development projects from the ground up. And spoiler alert, the ones that I like the most or the ones that I felt most productive in were the TDD or test-driven development projects. So yeah, maybe a little bit about what we're going to be talking about today. I don't know if we'll have the full hour or not. It kind of depends on how much I can ramble and how much you guys are asking questions. So we're gonna briefly tell a little bit about getting started, and then move on to what we really need for developing a product or any project or, for that matter. How we're going to achieve all the things that we need. Talk a little bit about how all those things might be impacting our productivity, and then how try and give some insights into getting it right. So extremely loaded term, getting it right, but you can only get there through opinions, and opinions are like noses. The censored version, everybody's got one. And then I want to kind of cap it off with an example, so that to make it all a little bit more concrete. So my previous presentation was pretty tactical. Yep, that's right. Pretty tactical, like, how do you do TD? Where do you start writing your test? And that kind of thing. So I want to talk a little bit about the strategic part as well, the more higher level concepts which carry over more than just the coding aspect, I would say. And as we discussed in the previous presentation, test driving isn't writing your tests after. It's basically you create your assumption and you write it down, you make it automatable if possible, and then you go from there. That was a little bit going ahead. So when we're developing a product, what do we really need? Why are we doing all this? What's important when we're developing a product or a project or pretty much anything that has any value? Let's say. Is there a question or something or other? Something in the chat? Oh, okay. I was already there. So when we're building our product or project or service or whatever, we really don't want any regression. That's like you build a feature, you release it into the wild, and then later on you realize that you had to make a change to your code and the code breaks. That's a really unfortunate situation to be in. So I think that's the number one thing that we want to go for is to provide, like, if it works now, it'll continue to work. Alongside with that, we want to be able to confidently add new features without breaking the old ones. We want to improve our existing features, like making it a little bit faster, a little bit easier to use, making the buttons a little bit more accessible. I don't know, stuff like that, which kind of ties in with our overall improving the product quality. We want to be able to do that confidently without introducing regression. We also want to experiment with our stuff because we all build assumptions and things need to be able to change over time. So that's pretty important. And then last thing I want to talk about is the speed to market, which is also a very driving force in product development. I know this isn't a complete list by any means, so I added the ... at the end to cover myself. There might be more things that I'm not thinking about right now, but I am not a product development expert. These are just some things that I jotted down to help me support my claim. Little disclaimer here. Cool. So, those are really bold claims that we're going to need, or really bold things that we're going to need when we're building our product, right? How do we get all that? Like, how do we get all this stuff done? So, what I know, this is my personal take on product development or iterative product development, is that you basically create an assumption like this feature is going to sell really well. You obviously never know until you do. So you build the smallest thing that you can find, you release it, you get feedback, you validate your assumptions, and you make it better. Right? I think that sounds logical in my head. If it doesn't, please let me know. And then alongside, we have our test-driven development, where we have the red-green refactor cycle. Maybe for those of you, I'll give a little bit of a callback to the last presentation. Red is the stage of the test where it's supposed to fail. Green is where you make it pass. Just by making it work, you don't get anything fancy going. And then you refactor, where you make the code look really readable, stuff like that. So in the red phase, we assume that we know how the code is going to work, and then when we go to green, we get feedback on how does it actually work. And when we refactor, we improve the code. So that does sound pretty similar, I gotta say, to the iterative product development. You build an assumption, you create it, you run it, and then you improve on it. So I like how things kind of fit together and have a similar feel to it. That kind of makes me feel like we can apply TDD to not just code, but to other stuff like our product development as well. You can say, write down in a document somewhere, we're going to expect this thing to happen, let it run its course, and then at a predetermined time, you could say, did we get it or not? What do we have to refactor to get there? So that sounds pretty good. All right. So, writing your, talking a little bit about the productivity aspect of TDD. That's something that a lot of folks seem to kind of struggle with, is when you write your production code and your test code, that means more code. So more code is probably spending more time, right? Well, yes and no. It's never a straight up answer. But typically what happens in a test-driven development environment is you start off a little bit slower, but then you get into this groove and you kind of keep it going from there. Whereas when you have a traditional environment, it starts to take longer because there's more manual testing. There's a lot more to the process than just run your tests and see it work. You know, I think ideally, thinking about it now, there might have been like a second line somewhere that said like, you know, when what happens with test after. But I'm pretty sure, you know, speaking from experience, that it's somewhere between the red line and the blue line. The red line, you know, the cost of change should be as low as possible, whereas with the blue line, it's over time the cost of change goes up, which is bad. Cool. I've been blazing through this presentation, so I'm gonna see if there's anybody that has any questions so far. Give you a chance to unmute and ask any questions. All right, cool. So speaking more a little bit towards the productivity that TDD can bring, and the why is TDD is a really effective communication tool. So you communicate with your code, obviously being the first and foremost thing, but also it's a way to communicate with your teammates and your future self and future other folks. So I'll kind of have to dig in and do some hand wavy stuff. But when you have your tests and your production code is how it works, but your test code is essentially your assumption of how it should work. So it's a really hard thing to put your how it should work into the production code, because you know you can come at it from here, you can look at it from all different angles, and at the end of the day, it's all just pulleys and levers. So your tests will ultimately serve as a reference to how the initial developer assumed that it should have worked if you do it right. Which means that the readability of your tests is extremely important. I would say just about as important as the readability of your production code, but we'll get back to that. So anyway, TDD is writing your tests beforehand is a good communication tool, because it helps you formalize your assumptions, get stuff on paper, and it'll give you a chance to reflect back after you've written your test of like, okay, before I go and implement all this stuff, is this really what I want? You know, is this kind of looking like the best possible scenario that I have here, or is there anything that I could do better? Creating when you're writing a test, you could be like, a user, what is a user? Do I need to be more specific here? It gives you a chance to jot down your thoughts, reflect on it, and then take action on
it. Hey Hans.
Hi.
Hey, yeah, Peter here. Sorry, I missed my moment here, but I just want to say, like, when you kind of get that sit-down meeting to start planning out your tests, right? How many assumptions do you try to tackle at once, or does it kind of vary depending how big? You know, like how many blocks of tests do you try to write in a given cycle? I guess does that make sense? Like, how many assumptions do you really try to tackle at once is a reasonable time?
Yeah, I would try to strive for a single assumption at a time, but there will, you know, when you're first starting your project, there will be a really big amount of assumptions because you have nothing validated yet. So you will most likely assume everything and try to live with that assumption. Like, as an example, you could say, I'm going to start with a REST service, and my REST service is going to, I don't know, give me product information, right? Maybe that's the best thing to do. Maybe there's better tools in the, in the market. But at that time, you don't really know yet, so you have to try, which is how, tying back to the experimentation thing. You can only validate your assumptions by trying and seeing if it succeeds or fails, and then taking it to the most minimalistic thing that you can think of is, like, let's say, instead of providing real data from some crazy infrastructure, you can just get started with, I'm going to need an order or a product ID, a product name, and a picture. Maybe that could be enough. And you could write your endpoint in a way that just returns an arbitrary order ID, a name, and then some picture you stole off of Google. I don't know, maybe you want to think about licensing when you steal pictures from Google. Up to you. I'm not here to pass judgment on that kind of stuff. But then you could write that in a test, and that's like a pretty safe assumption. And then when you hit your REST endpoint, you could be like, I'm not seeing my picture, because you just get a link. So maybe there's a better way to view your image, like a web page, or I don't know, whatever else, WordPress or something. So you get that feedback really quick.
Got it. So smaller the better, within reason, right? Okay.
Yeah, exactly.
Thank you.
So you want to feel like you're making progress, but incrementally, and like, the essence first. Like, Shok here has a really nice example of, I think it was Amazon Alexa, where initially, when they were bringing out the Amazon Alexa, they had people, listening in on your conversations and responding to your queries manually, rather than, building this whole complicated artificial intelligence system, because they wanted to validate the assumption that people would be interested in this stuff, and then they could get the actual data from the analytics to figure out, like, what are people really asking for? What do we need to build? So, good question.
Awesome. Thank you.
Whew. All right, taking a sip of water. Give you all a little bit to noodle in your head on the information that was just presented. Whew. Okay, moving on to the next slide. So then, now that we kind of know why it's important, why would we spend all this time to figure out what we want before we actually want it? Like, what are some of the ground rules that we want to set, barring the stuff, like the process of TDD? It's more the, here's where the opinions start to fly around, but that's okay. So as I mentioned, TDD is a communication tool, so we need to get really good at communication. And there's just no better way than to practice. So, writing your tests, and then instead of going into it really quickly and running your test and then implementing your feature and then going on to the next test, it's important to slow yourself and to really deliberate on your decisions, because every decision is a decision at the end of the day and can potentially come around and bite you in the behind. Like, if you decided, I'm going to use Java Spring and I'm going to build a REST endpoint that'll give my my picture, and you find out that your picture isn't being displayed through a REST endpoint, well, that was a decision you made, and you have to live with that now. So you either have to change it or deal with it. So there's this mantra in manual labor. I don't know if it's more specific than that. Maybe woodworking comes to mind. Is the measure twice, cut once. So we kind of want to do the same thing when we're writing our tests. Is like, is this the right test? Is this what we should be doing right now? Is there maybe something easier? Is there something more elegant of a solution that we can think about? Because right now, when we're writing our test, we're about to make a decision. Could be a small decision, like if should we return true or false, or 1 or 0. But there's still decisions. Another part of communication is listening. So listening to your code is also incredibly important. And as developers, or I might even say people, we tend to get stuck in our own heads. And sometimes it's good to be able to take a step back and say, what did I just do here? Like you get into this zone, state of mind where you're just delivering code and you're not even thinking about it. You're just so into the spirit of it that it's that at that moment it's a good moment to step back, look at what you just did, and then realize like okay, this is pretty okay, or maybe we need to tweak our code a little bit before pushing this to another environment or something like that. What's I think really important is to make your tests as readable as possible, but also something that is very often overlooked is the error messages. So you'll see like your code through an exception, and it's a runtime exception with unknown occurred. Something went wrong. We've all heard something went wrong somewhere with Microsoft or Google or whatever, and maybe that's okay for when you can't do anything about it anyway. But when you're a developer, you should be able to do something about it. So especially exceptions and production code error messages should be as readable as possible, because when you're coming back a year later to that particular piece of code, which through that particular exception, you're gonna be like, oh, unknown error, I don't know what that means, and you get demotivated by your own decisions in the past. So give your future self a break and invest the time in writing your assertions and your error messages in a very readable manner. So if your thing is hard to measure, or to listen or to read to, do whatever it is you can do to make it easier to be able to measure it, listen to it, or read it. Reading the test is maybe or reading code is the thing that we spend the majority of our time doing rather than actually writing code. So you want to also give your teammates a chance to be able to read your code and your tests. Same thing with measurements. Like if you want to measure your performance, and you want to be able to do it, you got to make it easy for yourself. There's no sense in finding a hard way and then just living with it, because if you need to change it, that's where you deal with those decisions again. So bringing it to a number of rules, they all kind of say the same thing in a different way, but I already alluded to it earlier. The test code should be just as important as your production code. There's teams out there, a lot of teams that don't even do testing, and other teams where testing is like, no, I'm okay with some duplication here, or it can be a little bit messy, I don't mind. Those kinds of perspectives. And in my experience, that just ends up costing more time, because at some point you will come back to the code and the tests and they will break, or most likely they will break, and you got to sift through the tests to figure out what went wrong. And having readable tests, clean code tests, really help you to figure out, oh, see, I had an assertion that um, my input was supposed to be this or that, whereas expecting that true was supposed to be false. Go figure. Unless you're doing Boolean logic, um, true or false carries very little business context. Like getting a validation error that the name should have been a limited number of characters, for example, is a better assertion than asserting that the whole thing is true. Getting in my head a little bit. I'm gonna take it back. Okay, so we hear this phrase red green refactor, but please always at least try to refactor, because it's very easy to be like, oh, we got our test passing, let's move on to the next thing. When you're writing your very first test in your very first project, there may be very little to refactor or not. And refactoring will at that point be very much assumption based, that we're going to need X, Y, and Z. So yeah, that's something you can make a decision on. But as you get more knowledge about your code, it's becoming more and more important to refactor, to have your code remain in a readable state throughout the lifespan of your project. So tying into the last point here is, you really want to make your code easy to read, to understand, because you forget what was in your head yesterday. I barely remember what I ate this morning, so similar effect to the code. If I look back on what I did in the past, I'm like, how did that work again? And really seeing it in a readable manner is really helpful. And every time, literally every time, I was like, no, it's fine. I'll be able to figure it out. I'm really coming back in the future and being like, I wish I had taken the time. At that point, if you're like, I wish I had taken the time back then, take the time now. There's no time like the present. So I like to give a little quote. I don't know if it's from anybody. If it isn't, it's mine now. When it's easy to read, it's easy to understand, which makes it easy to change. Very nice. So, wow, we're really going through this at a good pace. Any questions before we go into the practical example?
Yeah, I mean, well, it's probably a better one for the end one. It's more just like, as somebody who does tests, what's kind of your biggest pet peeve if somebody, in those powwows, right? Like, who somebody doesn't understand testing maybe, or the importance of it. Because I think that's a real thing. Is it, you just try to make sure that everyone's on the same page in the beginning, or is it like if a production, somebody's writing the production code, comes in there and says, I did this, kind of makes your blood boil? I mean, I don't know. I've never worked on any testers, so I don't
know. There's a few things that make my blood boil.
Fair enough.
I can't think of anyone right off the bat, but there's a number of things that I can think of that I would really like to shy away from. Okay, number one, long tests. It's just really hard. It's a similar thing with code. When you're writing code and you have a function that's 100 lines long, or even in some cases 1,000 lines long, there's just no way that you can really get feedback on that in a short amount of time. Like, I think that's probably the biggest thing, is just make your test short, succinct, and readable. Like, essentially, I want to be able to almost just look at the title of the test and be like, that's what's going on. You know, if you have like a level of abstraction, um, the putting the production code aside, your test code, your very first thing you want to look at is your test suite, which is the highest level of abstraction. Like we're doing our product inventory testing here. And then you want to dive into the test class, which is the concept or the smaller concept within your product inventory, like, I don't know, product endpoint test or something like that. And then your test name should be representative of what is going on. Something that might be pretty controversial. I'm not a big fan of the given when then in unit tests or in coded tests because there's a lot of additional words going on. Like you'll see a test like given the system starts up when the system has started up, then the system should have started up. Like you can just call that the system should start. You know, it's 3 words instead of 9, 10, and every word is a word that you have to deal with. So it sounds really minute in a sense, but all those things matter because when your tests fail and you see like when given all the stuff, you just want to know what the heck is going on. You know, oh shit, my system should have started up and it didn't. Why? You know, that's all I need to know. Similarly, you know, right, the long tests, you know, the long test names is one thing then, I guess already. The long tests by themselves. There's a lot of setup, there's a lot of making the code execute, and then there's a lot of assertions. That's really a tough one because that probably means that your test is doing too much or your level of abstractions are a little bit off or something like that. Something that I've also been extremely guilty of is shoving your long code into a test method, into a setup method, and I always end up regretting that. Ideally, you want to separate your concerns and make your concern easy to test. Um, so just being critical about the number of things that you're mentioning in your test is extremely important.
Got it. Awesome. Thank you.
Also, one more before I move on.
No, perfect. Yeah, no, perfect. Keep on going.
Is you know, slow tests. Test suites that are slow are just not gonna be run. You know, like if you will talk about it in one next slide, but you have your high level. I'm gonna run the whole system test, and then there's the unit tests, which are the code tests. You want to have as many code tests as possible within, you know, normal reason, of course, and they should all be really fast. They should be able to run very snappy because otherwise, you know, you just end up not running them. Cool. So leading into the practical example, I first want to give you a sense of the types of tests. I know that there's all these words floating around like integration test, end-to-end test, smoke test, unit test, uh, whatever type of test that you can think of. I don't really care for naming that kind of thing because everybody has a different opinion about what exactly is a unit or an integration or end-to-end. Uh, it all goes on different levels. Um, I think from my perspective, a test should start from the business. You know, what value do we really want to bring here, and what are the concepts that are needed to be able to deliver that kind of value. So, like when you're working with a project manager or product owner, you typically go talk about stuff like the product, the product endpoint, the product ID, all that kind of stuff. Those things are defined right there in a business test, often referred to as acceptance test, end-to-end test, that kind of thing. And those are your slow, really, it runs on the live system kind of tests, mostly. And then you have your infrastructure tests, where you still want to reuse your business concepts, but you have to add a little bit of infrastructure, like your Spring framework. It's kind of getting out of the way mostly, or tries to get out of the way. But like using HTTP, REST, gRPC, Kafka, that kind of thing. It has to have a certain place, and that is part of your infrastructure, and it should only be part of your infrastructure, because infrastructure makes your tests slow, right? And your business tests will depend on your infrastructure tests, so they will by extension also be slow, or not as slow, but still reasonably slow. So then we're all going to code not all of us, but some of us are going to code at some point, and we want to write code tests for the thing that we're developing, aside from any infrastructure that we can leave out of our application. Like ideally, don't do Spring, don't do REST, don't do databases, all that kind of stuff in your code tests. Take meaningful abstractions of those things, and then use, like, I don't know, arrays, lists, mock data, and use that in your tests. It'll significantly speed up your unit test, code tests, I'm gonna call them, runtime, and give you a lot faster feedback. And it'll be easier to swap out your Spring framework for whatever else there's out there, Dagger or whatever. Whereas your business logic is the thing that ultimately gives your business its money. Spring has no stake in how well your business is performing, so you want to chuck that off to the side, or the top, or the bottom, I don't care. So you want to use as little framework as possible in your code tests, and really just test the meaningful aspects of your code for the business. So again, here you want to use your business concepts, because we're talking about the product in the business tests and the infrastructure tests. It just makes sense to use them in the code as well. If you want to learn more about why that's important and how to go about that, there's a nifty little concept called domain-driven design or development. I don't know, one of the D's, called DDD. I don't feel qualified to give a talk about that yet. Maybe in one day. Essentially, what that means is you want to use the same language for your business and your infrastructure and your code, in a really oversimplified nutshell. Cool. So a business needs features, and the feature needs to be describable. Otherwise, how are you going to be able to do it? And I took a little bit of an example in Detroit. We're very into mobility, so I figured, why not take a car-related example? As a user, I want to be able to request a ride so that I can go from my location to my destination. So it's like a ride-sharing app or something like that. Disclaimer: this is not a real-world example. I just concocted this last night, and it is not real code. I haven't stolen this from anybody. This is not IP, that kind of thing. Cool. So we have our feature, we know what we want to do. It seems like a maintainable thing. So as we have our user story, I want to start with writing something that is testable. So given, this is where given when then is really helpful, I think, is in the business context. So given a particular situation, when this particular thing happens, then these things are the criteria for success, right? So in our example here, given a user is at a specific location and we have a nearby available driver, all these things are already concepts in our code. We have a location, we have a user, we have a driver, and then when the user requests a ride to their destination, then the driver should receive the ride request and the user's location so that they can drive to the user. Seems logical, reasonable, and hopefully achievable. So where do we take it from here? Well, we can start writing a test. I think we have enough information to pour this into a code test, or this could be an infrastructure test. You know, with the infrastructure, it'll be a little bit more wordy on like how do you make the request, but all that aside, I started this example from Java, but I wanted to take out the Java parts. So this is just more or less pseudocode where a test says that the user when a user requests a ride, it notifies the available driver. That's pretty much almost the user story in a nutshell. And so we set up our preconditions. Users at a location, our driver is at a location, and then the driver is available. This stuff all needs to go into the production code at some point. So this will be our public API for our code. You know. So then, when the user requests a ride to their destination, so this is where the logic or the business logic happens. Then we can assert that the driver has received a notification, and we can assert that the next destination for the driver is the user's location. I hope that kind of gels in your heads. This was my last slide. So once again, if you have any questions whatsoever, we have about 10 more minutes. So go nuts.